with the recording. Okay, now what I want to do is to share my screen. And then from there, we will officially start. Let's see who has joined. Okay, PT is back. It's fine. Let's see. Okay, so there are things that we can talk about. It's in most cases where it becomes very much easier when you study making use of the formula, which is what I would like for us to try and do. Let's start with the part of calculating the energy of photoelectrons. So when calculating the energy of photoelectron, we've got a formula which says E for energy, which is equals to the work function that you need to plus it with the kinetic energy. So very much important, honorable members, that you remember that in physical sciences, E refers to the energy. So that means that is measured in joules, that is measured in joules, that is measured in joules. So this formula, it tells us more about the energy of photoelectron. So that means that E, as you can see, it refers to the energy of light. So that means there must be a light which has the energy to do something. And that's something we will discuss it as we continue. So on that formula, we've got something called the work function of the metal. We will also discuss more on that. I'm pretty much sure that you guys are familiar with that being the kinetic energy. Remember, in this case, we are talking about photoelectrons. So that is why that will therefore be referred to as the kinetic energy of the photoelectron in this case. So that formula can be expanded where you've got the HF, obviously F referring to the frequency. Then again, we've got H, the frequency O. We will discuss more on that. Plus, obviously, the kinetic energy formula, we do know very well that it is half mv squared. So that is the expanded formula. Okay, let's maybe discuss some more. I will expand that so that we've got some more information to discuss. Remember, guys, I am well aware that you might have started with the topic. That is why I'm just browsing through that information, which I assume you are already aware of. This is just so that when we do some calculations, we will refer to this information. So very quickly, let's look at some conditions for emission of photoelectrons. I'm going to try and create a scenario which helped me to understand this topic even better. It might not be 100% relevant, but it is just for the purpose of us understanding what is happening there. Let me quickly check. PT, remember to remain muted, honorable member. I'll just mute from my side, but just make sure that your mic remain muted, just so that we are not disturbed by the background noise. might not need to worry that much. This lesson is being recorded. You and I discussed before I started with the recording, and you did indicate that you are struggling with a network. So I think best thing to do on my side, it is just to mute all, and then, mute. And then I'm going to say do not allow participants to unmute. And then I will make Augustino the co-host, just in case if I need to urgently attend to something, there's someone who's able to make me aware. Okay, then it's fine. This is what happens. Honorable members or members who are honorable. Let's say you've got a metal. That metal could be a spoon. Let's say you've got a spoon, honorable members. The spoon being a metal. So you've got your metallic spoon there. So from what I had to understand, honorable members, is that we have a sun there. Okay, that sun, it emits light. And it shines on that spoon. It shines on that spoon. Depending on how powerful this sun is, honorable members, depending on how powerful this sun is, meaning depending on the energy that this sun has, it has a potential to release or remove electrons from this spoon. If this sunlight, it is that much powerful, honorable members, if it is that much powerful, meaning it has a lot of energy, it will not only release these electrons, but it will release them onto the surface of that spoon, and because it has an extra energy, it will make these electrons to move away. So that means there must be an energy within the light in order to release these electrons on top of a metal. So that means there's a threshold. There's a certain amount of energy which is needed in order to remove those electrons. So that energy, it is the one which is being referred to as the work energy, the threshold energy. For these electrons to move, there must be another type of an energy. This is the one being referred to as the kinetic energy. So that means as a result of energy of light, two things happens. The first thing, the electrons gets to be released, and then secondly, depending on the amount of the energy that is by that light, the second thing happens. Those electrons, they will then move away. Okay, secondly, or another scenario, I had to think of something, honorable members. Remember, guys, what I'm explaining to you, it's what I had to conclude on in order for me to understand this topic. So you still have that sun over there, honorable members. You still have that sun over there. And then there you've got your house. And then in the house, there are some solar panels there. The solar panels, which then has to collect what is it? The energy from the sun, and then let us say store that into the battery. So that means the solar panels must be connected to the battery, and then the battery must be connected to, let's say, a light bulb inside the house. So this is how I have to understand what the electron is saying. Okay, the energy must then illuminate or shine on the solar panel. This energy of light, it has to be strong enough. That's why solar panel works perfectly when there is sunlight without the clouds. There must be enough sunlight with enough energy for it to then generate electricity. So there must be enough energy from the light to illuminate onto these solar panels, so that, honorable members, so that this powerful light, it must then be able to remove those electrons. That is that. The work function. Remove the electrons. Again, not only remove electrons, but it must also move those electrons. Move them to where? It must move them into the battery. That's why you will have the solar panels at the roof connected to the batteries, inverters, whatever the case may be. Let's say the batteries for now, so that it stores the electrons. Those electrons, honorable members, are the electricity. The electricity that will then, when you switch on, that light will then glow inside the house. So that means the energy of light must be enough such that it is able to release the electrons and then move them into the backup system or the battery. That's how we store the electrons. So that means this sun, it is able to then eject the electrons from the panels. That same sun must have enough energy for it to move the electrons. Where do they go? They go into the battery where they are being stored, so that when you come back from work, you will just switch on the switch, and then now you can start using the electricity. So that means the principle or the relationship between the solar panels and the sun is for the sun to eject the electrons, which goes into the battery, and then you have stored your electricity. So that means instead of you buying the electricity that goes straight into there, you use the sun, the light from the sun, to generate those electrons. You use the photo to generate the electrons, photoelectron. So that effect of the photo to generate electrons, it is the one that helps us to use the energy from the sun. Yeah, something of that nature. Remember, guys, I'm just trying to explain to you how I understood this topic, because you firstly need to understand the concept. Only after then we can go to the calculations. At least you'll be having a background of what's happening over there. Let me just quickly check if you guys have got any questions for me. I haven't discussed anything that has to do with the calculations. I'm just explaining to you how I had to understand this topic. So let's see. Augustino, Mbali, Biti, any questions up to this point? Based on
I don't have any questions on my side.
No questions from Augustino. Mbali, Biti, any questions?
No, sir.
No, sir.
Okay, no questions. Then it's fine. I'm going to mute and say no. And then from there, let us then discuss what you are seeing over there. So I hope you guys, you now have a better understanding of that formula, which says the energy from the sun, generally it is equals to the minimum energy which is required to release those electrons or to emit those electrons from the surface, plus the energy that moves those electrons. That is the full formula or a complete formula. So for a better understanding, let's look at the conditions for emission of photo electrons. So it's more like we are looking at the conditions which will result in electrons being emitted. From what? From the metal. Let's look at situation number 1, which is that one. You can see there they are saying if the frequency of the light, it is less than the threshold, what's going to happen to the electrons? So think of it this way, honorable members. Remember, what we use to measure the energy of the light is the frequency. The higher the frequency, the more the energy. So in example number 1, we are comparing two things. It's like we are comparing the energy that is required to emit these electrons from that metal. Let's say this metal, it's a solar panel. Let's say this is a solar panel. And to emit 1 electron from the solar panel, let's say it requires 2 hertz. Remember, frequency is measured in hertz. So that means the frequency that is coming from the sun, if it is less than, you see, if the frequency from the light or from the sun, it is less than that of the threshold, or it is less than the one needed to emit 1 electron, it means the electron will not be emitted, because you've got, let's say, 1 frequency that shines on that metal. It will not be able to emit an electron. Why? Because the energy is not enough. It's like you, honorable members, when you go to a lobola. For you to make the uncles speak, you must take out something, honorable members. You will take out 10 rand and they won't speak. BT. Then you take out 20 rand, they don't speak. What does it mean? It means the energy that you are presenting, it is not enough for them to react. So that means you need to go deep. Okay, 1.1 hertz, nothing happens. Okay, 1.5 hertz, they don't speak, Evan. Okay, 1.9 hertz, nothing happens, Evan. Then it means the energy that is required for them to react is not enough. That is that first scenario. Maybe let's look at a scenario number 2. When it comes to scenario number 2, you can see there is summarized. the photoelectrons are not emitted. Scenario number 2, we look at a situation where the frequency of that light, let's say it is now equals to the frequency of the photoelectron. What if now they are equal? The energy of the light is equals to that of the electrons or the photoelectrons. What happens in that situation? Okay, so remember we said we are having that solar panel there and we need 2 heads for it to start reacting. Okay, there it's you. You obviously started with 1 head, it didn't work. You started with increasing by, let's say, 0.5, so that means it was 1.5 heads. Nothing happened. Okay, now you take out 2 heads. The question now is, what happens when you do that? Okay, remember, it's you went to a lobola, and then now you were busy with a vulamlo. Remember, we haven't started with the lobola negotiations. You are still there by the gate, honorable members. You are still there by the gate. So now that you've taken out 2 heads, that is enough for vulamlo. What does it mean? It means it is enough for you to then say, okay, we can hear you. You are now speaking. What here for? Still at the gate, honorable members. So that means this is a situation where now you are not moving towards the house to start with the negotiations. You just remain at the house because the amount that you've taken out, which is the energy that you possess, is just enough for them to just talk to you. We're not going anywhere. We're still at the gate. We're just waiting. You've been greeting, you've been knocking, doing everything. They were just standing there looking at you and not saying anything. And you kept on taking out some more energy. Now that energy is enough for them just to speak. That is what happens at that situation number 2, where we say the energy of the light is equals to the one which is needed to just see a reaction. It is summarized there where they say the photoelectrons, yes, they are emitted onto the surface, but they don't have energy to do what? To move away. So they will just remain on that surface. Okay, so now the obvious situation, it is where now you have those, let's say those photoelectrons, and then okay, now you are striking with some more money. Let's say now you take out 4 heads. Obviously that one needed just 2 heads. So can you now see you've got an extra energy to make things move now. You've got an extra energy to make things move because you've taken out the energy that you have. It is equals to the minimum which is required to make them speak and an extra to make things move. So you see now you're moving from the gate to discuss the lobola negotiations now. Guys, it was tough. Sometimes we had to create a mini story to relate to these things so that we can understand them. Because otherwise, without this kind of stories, it becomes a bit challenging to remember what this topic is all about. And I'm pretty much sure that you guys have got a better understanding of what I'm trying to explain there. So without wasting some more time, let us now continue there. Let me do that. Okay, so as you can see over there, honorable members, we've got the E there, which refers to the energy of what? Of light. We know energy is measured in joules. That H that you saw from the formula, it is the Planck's constant. It is the Planck's constant. That means everywhere you see H, you will always substitute that, which is joules per second. Obviously, the frequency, you know, the frequency is measured in hertz. And then that WO, it is the work function. Volamlomo, it is that minimum energy that is needed in order to emit the photoelectrons on the network. That minimum energy, volamlomo. Never forget that one. Obviously, that kinetic energy, it is that extra energy that is needed to move those photoelectrons. So that means you must have that one plus an extra in order to move those photoelectrons. The obvious thing, it is V. We know most V, it is equals to a what? And again, we know it is the mass. Mass of what? Here we're talking about electrons, honorable members. So that means the mass of one electron, it is 9.11 by 10 to the exponent negative that kilogram. Very lightweight, meaning it's a very small mass. A small mass that the light needs to eject. So that is why the sun, as far as it is able to emit those electrons. Why? Because it's just a light weight, honorable members. Something very much important in addition to this information, honorable members, the formula which is used to calculate the speed of light. So that means as we discuss that formula, you must also remember this formula which is being used to calculate the speed of light, where we say C is equals to the frequency multiplied by that wavelength. And that speed of light, it is a constant value being 3 by 10 to the exponent that meters per second. So in other words, honorable members, the light moves very fast, very, very fast, honorable members. The speed moves very fast. Happy this thing, if you punch it on a calculator, honorable members, it means it is a 3, 1, 2, 3, 4, 5, 6, 7, 8. I think, yeah, something of that nature. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yes, meters per second. That's how fast speed can. So it means in 1 second, it can travel that distance in meters. Let me give you guys an idea of what happens there. You know, at a parking lot, you've got these things, honorable members, where you park your car. There you park your car. Is the parking lot. This distance is about 5 meters. So imagine how many of those 5 meters goes into that. So we are saying in just a second, that's how far the light will be in just 1 second. That is why when you switch on in your room, immediately or instantly, the light is all over the room. It's not like you switch on and then it takes some seconds before you can start seeing everything where you've or where your room is, where you've just switched on the switch. Immediately when you say, you guys get my point on that one. I'm just giving you a sense of how fast the speed travels. And we use that formula. Okay, I think I've covered all that I wanted us to discuss. What we can now do, it is to then look into some examples so that we try to make sense of all of this information, also to see how questions are being asked and how you answer those questions. And then at a later stage, we can then look into some exam type of questions so that you have a better understanding of how questions will come in exam and how you're going to answer those questions and how to make sense out of the questions. Maybe let me see. Any questions from your side, honorable members or members who are honorable? Augustino, Mbali, any question to this point?
No, sir.
I don't have questions on my side.
But do you guys understand what I'm trying to explain there, including the picture that I'm trying to portray there of the light, the Lobola negotiations and all of that? Are you guys able to relate that information to this topic?
Yes, sir.
Okay. Okay. Then it is fine. So now let us try to look into some examples. And then we will see how far we can go. We'll just say done on that one. Okay. Maybe let us start with this one, the first one. They say in the simplified diagram below. Maybe we might not need to start with that one. Yeah. Maybe we might not need to start with that one. But let us start with this one. Yeah. Okay. Let us start with this one. Let's see. They are saying a metal surface. When they say a metal surface, you can just always think about a solar panel. It makes it very much easier when you think of a solar panel. Meaning, a metal surface is illuminated with ultraviolet light of wavelength 330 nanometers. They are saying electrons are emitted from the surface. Nay. So number one, it means the energy that the light has. it is enough for it to emit electrons. Okay, now they say the minimum amount of energy required to emit an electron from the surface of this metal is that. So they've given you their price tag for vulamlomo. Okay, so now you are given that drawing there. And you can see already to say on that drawing there's ultraviolet light. So that means two things are happening. Electrons being emitted and then at the same time moving away from that metal. So it already gives you an idea to say you've got the light has got enough energy for vulamlomo and an energy to go to the house for the negotiations. So now they say, name the phenomenon illustrated there. Anyone who would like to give it a try to name the phenomenon which is illustrated there? Cristiano Bali, you can just mention your name if you want to give it a try. If you've got no idea, again, just mention and say no idea. Guys, do you have an idea on that one or no idea? Augustino, Bali, do you guys have an idea or no idea? Evan. Guys, are you still there? Augustine and Bali, are you guys still there? Remember, if you've got no idea, say no idea so that I'm aware and I will explain.
Sir, I say I'm not that sure.
Go for it. How would you then answer this question which says, what is the phenomenon illustrated there? Okay, I'm not sure how you will cram this one, but it's always an easy one. When they say name the phenomenon illustrated there, normally it's given 1 mark. You just say it's photoelectric effect. Photoelectric effect. You just name this topic because what we are seeing there, it actually illustrates photoelectric effect. That's it. Just 1 mark. So that means it remains your responsibility to always notice if the answer that they want you to provide is photoelectric effect. I'm just saying sometimes they might not straight away say name the phenomenon illustrated there, but you might find that word phenomenon being there, or maybe something that has to do with whatever illustrated or whatever that is depicted there, something of that nature. It's always, not necessarily always, but in most cases given 1 mark. Just know it is you just stating that this is actually photoelectric effect. Okay, let's go to number 2. Give one word or term for the underlined sentence in the above paragraph. Okay, that one also. Anyone who would like to give it a try, that one. What is that word or term for the underlined sentence? There is the underlined sentence in the statement. Anyone to give it a try? Augustino? It's only Augustine. Okay, Augustino, do you want to give it a try, or you've got no idea so that I explain?
Sir, I have no idea.
In that situation of the lobola and whatever, do you not remember what that is? Maybe let me explain. Do you still remember what is represented by volamlomo in this topic?
Sir, is it like the energy which is emitted by the sun?
No. It is that minimum energy. Is this thing? I'm not sure if you remember, Augustino. It is that minimum energy which is required to emit electron, the work function. I'm not sure if you remember now. You see, that minimum amount of energy required to remove, or that is required to emit an electron from the surface of the metal. Do you not remember now, Augustino? Volamlo. Hmm? Are you still there, Augustino?
Sir, yes, sir, I'm still there. I'm still here, sir.
But do you now remember Volamlo?
Yes, sir.
Yes, so that is the work function. So you must always remember that minimum, there you can see that word for the minimum. So that means that minimum amount of energy that is required to emit electron from the surface of the metal, it is the work function. It is called the work function or the threshold. It is the minimum. Now it makes sense, Mos Augustino.
Yes, sir.
Okay, so now they say calculate the frequency of the ultraviolet light. Do you have an idea of where you are going to start that one, Augustino?
Sir, aren't we gonna use the wavelength formula to calculate
Yes,
the system?
yes, you're going to use that formula which says C it's equals to that multiplied by that. Obviously, this one is a constant, and then you were given that one. You just need to remember to convert it from nano to meters. I think nano n used to mean 9 for me. By 10 to the exponent, wait, is it -9 or +9? Wait, I forgot if nano is negative or positive. But whatever the case may be, we'll just verify that one. You just need to remember that you need to perform that in order to calculate to convert it to meters. Then that's when you can substitute it there. You know that one is a constant, And that's how you will get the frequency, which is measured in hertz. That's how you score yourself 3 marks. Does it make sense, Augustino? I think you're going to get it
Yes,
correct,
sir.
but in terms of the nano, you are not going to forget to convert it, Mos. I'm not sure if the other honorable members are still there. If it is just the two, okay, still the two of us, it's fine. Okay, so now, Augustino, they are saying calculate the kinetic energy of a photoelectron emitted from the surface of the metal when the ultraviolet light shines on it. Any idea of how to work out this one, Augustino? Augustino. Augustine is gone. Possibly the network. From my understanding is that it's in most cases where at 8 o'clock things start to change. But it's fine, I will just explain that one. For the fact that they said calculate the kinetic energy, it means this is what they want you to calculate, the whole of that, meaning your final answer should be in joules. So it means you will therefore have to take this to the other side, meaning you've got your kinetic energy, which will therefore be equals to that energy of light minus the work function. Obviously, we know that the energy of light, it is Planck's constant multiplied by the frequency that you calculated. You will minus that by Planck's constant multiplied by that. But remember, in the statement, you were already given that as the energy. So that means you will substitute it as the energy. So your substitution will be for the Planck's constant, the frequency that you calculated, minus the energy that you were given in the statement. You punch all of that in your calculator, and then you get your answer in joules. So that's how work out that question. I'm not sure if there's someone who has joined or if I'm still alone, but I'm just explaining because this is a recording. You will then be able to catch up. Augustino, I explained that question number 4. Maybe very quickly, let me explain the last 2 questions and then we'll leave it there. On our next lesson, we'll then go deep into some more questions. So question number 5, they're saying the intensity of the ultraviolet light illuminating the metal is now increased. So they're just increasing the intensity. Now they're saying, what effect will this change have on the following? Now they're saying on the kinetic energy of the emitted photoelectrons, you just write increase, decrease, or remain the same. Yes, remains the same. So when the intensity increases, it doesn't affect the energy. It's like they are just increasing more lights of the same energy. It's like increasing more sun lights. Let's say that was the metal. There we had the light. So let's say we had those sunlights which were shining up to that point. when they say they increase the intensity, still from that same source of light, you are just adding more sunlight. So it's like it was cloudy, but now the cloud has moved away. So you are just increasing more sunlight. Which is being referred to as the intensity. But from the same source, which hasn't changed. So this will not increase the energy, but it will just increase more electrons which are being emitted. So that means more of those, more of this being emitted, more of this, more of that, more of this, more of that, more of this, more of that. But it does not increase the speed at which those things are leaving that metal. It doesn't increase the speed, therefore it doesn't increase the energy. It's only if the frequency of this, increases, then that will increase the energy emitted. But when we talk about the intensity, it doesn't influence the energy. B, now they're saying number of photoelectrons emitted per second. Now I've just explained that one. So that means more of the intensity, the more those are living. Yes. So that's what I wanted to explain on that question. Maybe let me check before I sign out if you got it, Augustino. Let's see. Any questions from your side, Augustino?
No, sir.
No questions. Okay. Then it's fine. I will then sign out, Augustino, until we meet on our next lesson.